Hi, everybody. Welcome to our fourth Solution Series webinar for the year. Thank you for attending this. I think we've got something exciting to show everybody. 3 years ago, we started doing business with a company in the UK called Sontay. And I'll be introducing you to Donal Lynch, who's the international sales manager for Sontay. He's been with Sontay for 14 years. I was looking for a product that would be unique in the market space to show everybody. And Sontay is a company that has some unique solutions, and they've got all high quality products. Their sensors, their switches, their wireless product is just a cut above what most manufacturers are offering. And they've got solutions that I think are unique. I think you'll find them unique too. We've been working with Sontay for 3 years now. We stock their products at our sister company, Building Control Parts, here in a suburb of Pittsburgh, PA. So when you order the Sontay products, they ship right out of a warehouse deal that we have locally. I'd like to introduce you to Donal Lynch, my friend. Donal, you want to talk about, we're going to talk about two products that Sontay manufactures, not their entire line. Feel free to look at that online, but Donal's going to talk about their smart sensors, their communicating smart sensors, and their wireless product. So without any further, Donal, go ahead.
Thank you very much, Dave. Hi, everybody. And it's a pleasure to be here to speak to you all from Ireland, where it's currently 7 p.m. So it's been a long day, so I hope I can do the next few minutes justice. So today I'm going to talk about two products in particular. So there's the Sontay Smart Communicating Sensor, and there's the second one is Sora, which is a LoRaWan based wireless sensor. So I'm going to go to both of them together, and I'm going to take questions at the end. So feel free to submit questions right through the presentation. There's a little box on that you can type in your questions, and we will gather them together and answer them at the end. So I'm going to start a little bit with a definition. So there's a lot of talk about smart buildings, smart sensors, smart communicating, all of that, right? But what does it actually mean? So I'm just going to read the definition and talk a little bit about it. So it's the ability of a building or its system to sense, interpret, communicate, and actively respond in an efficient manner to changing conditions in relation to the operation of technical building systems or the external environment and to the demands of the building occupants. So, and that's a bit of a mouthful, but the one word that stands out there for me is sense. The sensors in any building do a really important job, and people pay an awful lot of attention to what they do with the data and logging the data, optimizing the data. But if the data isn't accurate and correct to begin with, then the whole system falls down. So the sensor itself is the most important part of that. Get that right is really, really important. So I suppose, why use a smart sensor? So there are a number of benefits, I suppose, of using a smart sensor. So it's a simplified installation. It reduces the time on site. So reduction in time obviously results in a reduction in costs. There's seamless communication of the data for the building lifetime. There are benefits both for the installer, but also for the end user, and it fulfills our ever-growing demand for visible building data. So the first product I'm going to talk about is, as I said, the smart communicating sensor. So on this particular one, I'm talking about the space version, the wall-mounted version. It is also available in other versions, in a duct, immersion, etc. But just for today, I'm going to talk about this particular one. So this particular model has BACnet MSTP and Modbus RTU communication as standard on the sensor, so you don't have to specify which one you need at the time of ordering. So what's really good about this sensor is that it can actually sense 7 different sensing functions. So you can specify the product according to your needs. So you can have any combination you like of temperature, relative humidity, carbon dioxide, carbon monoxide, air quality. And when I say air quality in this sense, I mean VOC, light level, and occupancy. So there are 7 sensing functions, mix and match in any shape or form you wish. Then we've got a whole bunch of interface options. So we've got a set point adjustment wheel for the user to set the set point. There's a momentary switch, which is a really important one that just changes state. So it means that you can use that button to do whatever you want from a programming point of view. An example might be a run-on timer, give it a boost for 10 minutes, something like that. That's completely up to yourself what you want to use that for. There's a fan speed, a slider there for a switched fan speed. There's an LCD display, and that LCD display has many different possibilities. I think there's up to 16 different combinations of what you can display on that screen. So you can display all the values, or you can choose to hide some values and only give the user access to a particular set of results. And the last one there is an LED. So this LED is particularly for CO2, and it's a visual representation of the CO2 levels. So traffic light system, so it's red for high levels of CO2, it's going to be green for acceptable levels, and amber or orange for the in-between. So the next part is what then separates this product out from lots of the competition. So we've got some inputs and outputs on this device. So the input is there as standard, so that's configurable. So it can either be an analog input, which could be 0 to 10 volts, or a thermistor, 10K3 thermistor, or it can be a digital input, which will be like a volt-free contact or a pulse counter. So to explain what this means, you can take that input and it gets transferred to a backnet point or a Modbus point, and brings it over to the controller. So all the control happens at the main controller. So you continue to use your controller, whatever you're used to, Honeywell, Johnson, Siemens, Allerton, whatever you normally use, whatever you're comfortable with, that's going to be where all the control happens. So this unit essentially is a sensor with some dumb I/O. So this unit does not have a PID loop or anything else built in there. It's purely a conduit. So on the output side, and this is one that's really cost-effective way of doing it. Actually, there are 2 digital and 3 analog outputs available as standard. So I have a further slide that can show some of the examples of what can be done here. But this means that you can just wire to your local sensor. So you can wire a fan or an actuator or something like that, just to your local sensor, and you're controlling that output directly from your main BMS controller. So the next slide shows a little bit of where the cost savings can be made. So if you need to sense multiple sensing functions, so as example, temperature, relative humidity, and CO2, the ways to do that, you can either have 3 separate sensors, all needing to be wired individually, or you can use a multi-sensor, which there are loads available on the market. But even with a multi-sensor, you've got to wire each one of those outputs separately. So a set of wires for the 0 to 10 volts for the temperature, relative humidity, and CO2. That's a lot of cabling. So you can see on the bottom of this of this graphic, when you're using a smart sensor, so a communicating sensor, you're just using one set of cables. So it's a twisted pair of cables, and all the data is sent via this one data bus. So you're going to need a 4-core cable, 2 cores for the power, 2 cores for the data communication. So that's going to save an awful lot of money. And remember what I said about the outputs on this same 2-core cable. You're now controlling the outputs as well. So you can control the valve, actuator, whatever. So the next slide shows maybe some of the possibilities on that one. So remember, you've just got a sensor on the wall, but by wiring into that, you can control things like heater batteries, or heating, cooling, variable speed drive, fan speed. So some examples of that might be if the CO2 levels go too high in a particular room, it could switch on a fan locally. So instead of wiring that fan all the way back to the BMS unit, you're just wiring it into the local temperature sensor, or the local sensor, and from there you're controlling it via the main BMS. Another example might be, if the temperature drops, you may be just opening the valve on the radiator or something like that. So all of that can be done automatically. So, but the point is that this gives us an awful lot of flexibility to be able to engineer a job in a cost-effective manner. So the next slide, I suppose we've always designed products with the user in mind. That's one of the things I think that sets us apart. And I just wanted to maybe mention some of the features under the hood that just make it easier for the installer. So the first one is a series of LED indications. So they appear on the bottom right of the PCB board. Now that might seem like a very simple thing, but you'll be amazed how many manufacturers ignore this. The lights, the LEDs are on. You know that it's powered correctly. You know the inputs are working. You know the outputs are working. And if something is flashing, you know it's very, very easy. If you just ring technical support, straight away they know what the problem is based on what's happening with the LEDs. So very, very good for fault finding. The second one being that the terminal blocks are removable. Anybody will tell you that, especially in modern products, that the terminal blocks are miniature. It gets very, very difficult, especially if you've got fingers like me, to try and wire these units up. So by just popping out the terminal block, it's very, very easy to connect. And the last one is a feature that I really like. It's a test button, so you can cycle through the outputs right there from the board. So you don't have to go back to the panel and ask your colleague to send a signal. You can do all of this directly from the board. So some really nice features. And just to finish with this particular one, I'm just going to use an example of where we used it. So in my home country here of Ireland, we worked with a local system integrator to fit out this building. So it's the Department of Agriculture, Environment and Rural Affairs in Northern Ireland. So it's a very modern building, a glass-fronted building, and relies heavily on natural ventilation. So by that means that the windows can be opened or dampers can be opened to give fresh air into the building. So again, you will have to use the flexibility of these sensors to give the functionality that's needed for this particular building. So the CO2 was the one that's being controlled, and dampers were being opened directly by the sensors to control this building. So very nice example of how these sensors have been used. So that brings an end to the first part, and I'm going to move on to a product range that we're calling Sora.
Donal, before you do, can I just add something here? I think
Sure.
The highlights of the product are, of course, the 7 multiple sensors under one hood, the significant reduction in wiring cost, and significant reduction in I/O points onto your building automation system, whatever brand you're using. And this sensor is not a controller; it's just a sensor. So you're doing all the controlling in your native product that you're a dealer for, a rep for. And you're just using this product as a collection point of the data and an output base for some of the output to save you I/O on your module. And then I think the push button and the diagnostic features under the hood are important also. So I think the product's a win-win, and it is stocked here. I believe it has free freight. It's stocked here in the U.S. and it's a high-quality product. I hope you have questions that we can help with later. You agree with me that this is a unique and special product. I'll get on to the second product that Donal wants to show us. Go ahead, Donal. Sorry.
Thank you very much, Dave. Yeah, really nice summary there. So the second product is the most recently launched product by Sontay. It's our trading name for it is Sora. It's based on LoRaWan wireless technology. Now, I suppose this technology has taken Europe by storm, and I'm very confident that the US will go the very same way. We've launched a range of sensors, as I said, on this one, temperature, humidity, and CO2. But I'm going to maybe take a step back and just talk about what LoRaWan is. So it's been around for quite a number of years, at least 10 years. So it's not. I'm not trying to sell the technology or this technology is a proven technology, particularly in other sectors. It is still new in the building automation sector, but the robustness of the LoRaWan network is already proven. We've just built a bunch of sensors to use that infrastructure effectively. So LoRaWan it's a long range, low powered wireless system. It operates between 800 and 900 megahertz, so quite a low frequency, and that low frequency allows long distances. There's a whole LoRaWan alliance forming out there, a bit like the BACnet alliance that many years ago. And if you go onto their website, there are hundreds of manufacturers at this stage that have joined. And every week I go on there, there are new manufacturers. So it really is where the wireless sensing seems to be converging, and all the other systems that were there are certainly becoming redundant. I suppose on this one, the data is secure, so it's all encrypted. So there's no fear that the data will be intercepted or used in any way illegally or anything. The cabling is to an absolute minimum with this. It's a wireless sensor, but you have an option of using some cables if you wish. There's a long battery life on there, so you can have a battery life of up to 10 years. And the last one there, which is the long range and deep penetration into, especially in the building environments, is going to make this a really good solution. So I suppose what we've launched to begin with is the three most popular sensing functions. So temperature, humidity, and CO2. So we can do 1, 2, or 3 of those in any one sensor. And we've done it in our wall-mounted space sensor, and we've also done it in the duct and immersion, and we've got the clamp-on version. So we've got a range of sensors in this range. So the sensor accuracies are pretty much what you would expect. Plus or minus half a degree C, plus or minus 3% relative humidity, and plus or minus 30% or 30 parts per million. So each one of these units uses 2 batteries. They're a 3.6 volt lithium battery. So they are the same shape and size as your typical AA battery, but it's slightly different. So AA won't do it. It is a particular battery, but it's not a specialist battery in the sense that it's very easily got. There are hundreds of vendors everywhere selling these batteries. It's quite a common one. So I suppose how does the sensor itself communicate? So on this particular one, so it's a star topology. So in other words, you've got one hub in the building, and all the sensors communicate directly with it wirelessly. So you don't need repeaters or routers or anything like that in the building. It's direct communication to the hub. And the hub is a whole different discussion. And we don't manufacture our own hub. We do offer one, but we're not the manufacturer of this hub. So there are lots of different hub manufacturers out there, and that's what they specialize in. We are a sensor manufacturer, so that's where our area of expertise is. But we are offering this one. It's made by a company in France called WattSense, who are part of the Siemens group of companies now. So you will see this product on the market with the Siemens badge on it as well. And we've got an OEM agreement to have a Sontay badge on it. And the reason we've gone for this one over the others that are on the market is that it's so easy for a building automation engineer to set this up. It's really very, very easy. You don't need to be an IT expert. So it's very, very easy. So all you do is the sensors come in as LoRaWan wireless sensors, wireless points, and on the outside they come back as BACnet IP or Modbus IP, or in fact MQTT, which is an IoT protocol. You can offer all of those as outputs. So very, very easy to map those points across, and any BMS engineer will know what to do with those BACnet IP points, and you control in the very same way as normal. So some of the features on this particular one, there's a 3G or 4G modem built in there, which means you can access that data via any web browser. Just put in the web details and you can access it. Obviously via passwords, and it's locked out and all of that. As I say, LoRaWan is at 863 megahertz to 928 megahertz. It varies slightly from region to region, and each region needs to be certified. So we've had this on the market for several months now in the European market. The European market uses EU 668. So that's already in place, and we've had we've lots of installations and that we can talk about. Australia uses a slightly separate approval system. It's called AU 915, and in the US, which is obviously the one that you're going to be interested in, is US 915. So both the US and Australian certification process is happening right now. It's just going to go through. It's a paperwork exercise. It's a cost exercise as well, and that's just the nature of these things. But at the moment, we're in the final stages of testing on that. So by the end of the month, I hope to be in a position to be able to announce that it's certified for use in the US. So just in terms of hubs, there are lots of different hubs out there. Some of them specialize in cloud-based systems, so you can just access the data over a cloud. But we particularly wanted one that BMS engineers could use as inputs on their normal building automation system. So that's pretty much with the hub. The battery life itself. So if you take the default position, and the default position is that these sensors send a packet of information every 15 minutes. So every 900 seconds, you're expected to get 5-year battery life if you're using temperature only. That drops down a little bit if you add a humidity module to 4.5 years. It does drop considerably, but it's still 1.5 years before you have to change batteries if you add CO2. CO2 module itself is quite, relatively speaking, is a higher consumer of power. But there are ways of mitigating all of this. For some, maybe non-critical applications, maybe every half hour is enough to have this information being transmitted. And in that case, you're doubling all of those battery lives. So you get 10 years from temperature only, as an example, if it's every 30 minutes. One of the things, and maybe talk about this on the next slide, we used to set up, so we have an app. So there's an app available for the mobile phone for Android and Apple. And with this, you can use it to set up the parameters. So it uses near field technology. So you literally just tap the phone on the sensor, it extracts the information that's there, and from there you can change the parameters. So the main parameters you want to change is how often you want that information being sent. So as I say, the default is 900 seconds. You can bring that right down if you want to 60 seconds if you wish. The other one is the change of value. This is an important one. So even if you spread it out to 1 hour, you can put a change of value in there so that if the parameter changes by, let's say, 1 degree, send it immediately. Don't wait until the next time it's due to send information. Send it immediately. So that allows a good level of control. If you have a particularly sensitive installation, or maybe one where you don't want to go back onto site and you don't have a maintenance contract, in other words, you don't want to go changing batteries, you could actually power these units if you wanted to. So they still transmit wirelessly, but you could put a 24-volt supply on there if you were in any way concerned about battery life. Next, I'm just going to speak about the signal strength. So I suppose this is what sets LoRaWan apart from other systems out there. We had a previous version, a previous wireless offering that operated at 2.4 gigahertz. So that's the same frequency as Wi-Fi. And we all know in a building where you can get areas where you just can't get a Wi-Fi signal for whatever reason. That's the 2.4 gigahertz, which is quite a high frequency, relatively speaking. LoRaWan operates at a much lower frequency. So as a general rule of thumb, the lower the frequency, the higher, the further the penetration of the wireless signal. So the wireless signal is measured in dBms, which stands for decibel milliwatts, which is a bit of a strange term, and it's in the negative. So the closer to zero you get, the better the signal. So as you can see, closer to the sensor itself, zero is a perfect signal. It's never going to be zero. But as you get down along the minuses, so an example, minus 50 would be better than minus 80 in terms of signal strength. The good thing about LoRaWan is that even if you get a poor signal, and you could be all the way down at minus 120, and relatively speaking, it's a poor signal, but because it operates on a narrow bandwidth, you're still going to get that signal through and you can still read. So that allows you to have very, very long distances on LoRaWan. So I'm just going to give maybe a small example and maybe just a little bit of a fun fact. So Tony Day is our technical manager, and he's been with us for more than 20 years. Might be a little bit biased to say it, but I think he's one of the best in the business when it comes to tech support. But anyway, when we were launching this product, we just said, let's do a real life example. So he put the hub on his desk, just in the downstairs office on his desk, and he went on his bicycle around the locality where we operate from, which is in Edenbridge in Kent, just near London. And as he got around through the hills and the valleys around Edenbridge, he was still getting a good signal at a distance of 1.2 miles away from the office. And that just shows how far that this unit can go. So that's 1.2 miles away from the hub that was just sitting on his desk. So this wasn't hanging out a window or in line of sight or anything. This was literally sitting on his desk, and he could still read it 1.2 miles away. So that sort of shows the strength of this SORA range. Again, just in terms of a summary on this one, easy installation, no wiring, long range, low power, which is becoming more and more, I suppose, of a topic at the moment. Easy integration with a BMS controller. So most controllers these days can accept BACnet IP as an example. So by using this hub or the Siemens one or anyone you want, actually, in fact, you can integrate it very easily. I should have mentioned, interoperability is the thing. You can choose to use our hub or anyone else on the market. We just give you all the information that you need to set it up. And the other thing is that it's a proven technology. It's been in the market a long time. We're now just adapting it for our industry. I'm just going to give you maybe one example of where wireless sensing can operate. So this was an installation that we did, and I must admit it was with the previous range of Sontay wireless sensors, but it's the same principle. So our sensors are installed in the Guildhall Art Gallery in London. So this is where the famous Magna Carta document is stored, and so having temperature and the relative humidity correct in these buildings is crucial, because preserve the artifacts, the artwork, and the documents. So this is our wireless sensors were able to be installed without closing the gallery. You can walk around the building and put sensors on walls and get readings very, very quickly. So it's very, very easy to install, and that's just maybe a typical example of where it could be used. So that brings my presentation to an end, and I'll maybe just hand you back to David if you have any more comments to make on that one.
Well, no, it's proven technology, and the distance and battery life, especially in buildings like the one you're showing in the picture. I remember doing a job at a museum that was all stone walls and granite, and we didn't have this wireless product available, and the cost of installation was through the roof years ago. I'd like to show everybody where you see these two particular technologies in our catalog. So when you come onto the Alps website, if you go to manufacturers and slide down alphabetically to Sontay, and these are the categories of products that Sontay has on our site. Scroll down to the category temperature sensors. And over on the right, room sensors would be the first product that the smart communicating wall sensors and sensors. These are the four primary SKUs. We're showing you what's available in stock right now. If we get product movement on this thing, we can ramp up stock to whatever needs we need. The pound signs, remember, indicate that there's configuration required. The bottom product, the SC-S, has 6 pound signs that you need to choose which combination of features you want on the sensor, and place your order. But Alan, could you just go back to the Sontay general categories? 2 screens back, I think, or 1 screen back, maybe. Yeah, so they've got all these different types of products. They've got light level sensors, they've got moisture sensors, combination analog value sensors, and duct humidity, duct pressure, air quality, et cetera. They got a whole lot of products. Most of these products Sontay manufactures. Some products they import from other brands in the in the world, and they're all available on our site. And I believe almost all the products include free freight from Pittsburgh. Well, so now, Alan, I'll turn it over to you for questions and answers.
Okay, thanks very much. And thanks for everybody who's hung on here with us. And we're going to get to your questions now. I see that we have a whole bunch in our queue already, so we'll just get right to them. Actually, this first question came from a customer who is not able to attend today, and he sent the question through our sales rep, Tracy. And so I'm going to read this exactly as he wrote it because I have no idea what this means. It says, what is the difference between the LoRaWan gateway and the Dingo box running Dingo Stack?
I'm afraid I have no idea what a Dingo Stack is. Maybe it's a American solution, I'm not sure.
Yeah, I don't know what that is either.
Okay, well then we're all in the dark, I guess. We'll have to get back to him and find an answer for him.
But I think the key that Donald talked about earlier was that he didn't care whose router you use. So if you've got, like we sell the router that was on his slide from a company called Cloud Connect, I think, or Motion Cloud licenses. They've got a license for that same router, and we've used that here for their software and sensors, LoRaWan sensors, and it worked great inside our building, 3-story building, concrete floors, concrete walls, and it worked great. But you could buy anybody's router, I think.
Absolutely, there are loads of them on the market, and in fact, there are some publicly available routers as well in hubs and in Europe, and particularly in France, they seem to be, maybe a few years ahead of everybody else when it comes to LoRaWan. They were early adopters. There are whole cities that are LoRaWan enabled. So there are publicly available hubs, in the street that you could just put your sensors in a building and pay a fee to whoever owns those publicly available hubs and access the data via cloud. So that's possible, and I think that's the way it's moving. But there are ones that specialize in cloud-based. But as I say, this particular one that we have is especially for building automation. So.
Okay, we have 2 questions here that seem to be closely related, so I'll give them both to you at one time. The first one says, what distance can be achieved between a sensor and the hub in a typical indoor environment? And then can the wireless signal travel between floors in a building?
Okay. I'll take the second one first. Well, the answer is yes, absolutely. It can go between floors. I'll give an example. I was doing a site survey recently in a museum in Antwerp in Belgium. And I was, the panel where the hub was going to be located was in the top floor, and I was still getting a good signal 5 floors down. And it was an old European-style historic building with thick walls and thick floors, and I was getting a signal 5 floors down. So I know firsthand we can go between floors. In terms of distances, right? So LoRaWan themselves, if you go on their website, they are saying that in outdoor space you can get anything up to 10 kilometers, which is 6 miles. That's whether that's realistic in practice or not, I don't know. But within a building, it very much depends on the fabric of the building. So there's no real definite answer for that, right? But we've always been saying to people that 200 meters, which is about 600 feet within a building, and I think that covers most buildings, is very, very comfortably achieved. So that's the answer I would give. But there are caveats in there. It depends on the building, the fabric of the building, whether it's steel cladded buildings and stuff like that. It can vary between buildings. So the quickest way is to do a bit of to do a test, and we have some test kits available that can be tried. I know Alps Controls has access to one and can loan it out to people if needs be. So maybe that's the best way to try it and see before you buy, sort of a way of looking at it.
Okay, our next question is there an ongoing cost or subscription needed to access the hub via the web portal?
Good question. The answer is no. So the Watson, who are the manufacturers of this, have an inbuilt SIM card that can be GSM card, and it's free. So once you buy the hub, you don't need to pay any extra fee to access that data. They're guaranteeing that it's free for 3 years, but even after that, it's going to be an absolute minimal cost. But the thing is, you won't need necessarily to access that information, because once you have the building set up and commissioned, you're seeing all of those points coming through as backnet points on your BMS anyway. So you won't need to go and access it, unless maybe you have to add extra sensors or something down the line. But generally speaking, once the job is commissioned, you won't need to go back and access the hub again. But it is free for 3 years anyway, so you're pretty well covered.
Are there plans to expand the range of sensor options available?
Yes. I think I said at the beginning, this is phase 1, and we went with the most popular sensing functions, so temperature, relative humidity, and CO2. And like we always do, we listen to customer feedback, and we again, and that's probably something that we could ask all of you afterwards. Then, what other parameters would you like? So at the moment, we have a project manager that's solely responsible for the next phase of this development, and he's looking for customer feedback, actively looking for customer feedback at the moment to know what the next most important functions are. From me talking to customers personally, I think they would like a wireless I/O module as an example. So something that could convert wireless signals to actual outputs. So 0 to 10 volt outputs or something like that example. So that means you convert pretty much any product to a wireless product. So to me, that's the front runner, but that's not decided yet. So we're at that phase at the moment where we're assessing.
Okay, we have a question that says, do you expect the product will outlast the battery, or do you expect an upgrade will be needed before the battery ever fails? Or is it easy to change the battery?
Very easy to change the battery. The battery is literally as easy as changing changing a AA battery on your kids' toys. It's that simple. It's literally just remove the battery, replace it. That's it. So very, very easy to remove the battery. I expect the product to outlast the battery. Yeah. So I would expect the batteries to have to be changed maybe multiple times, and the sensor still operating. So.
Okay, one of our viewers would like just a little bit of clarification. He just wants to understand correctly. The LoRaWan sensors communicate to the hub, which is able to integrate to a BMS through BACnet IP or Modbus TCP. Is that correct? And the sensors are battery powered while the hub is 24 volt.
Absolutely. This person has got it in one. Yeah, absolutely. So the hub basically converts the LoRaWan wireless signal that's coming from the sensor and converts it to the BACnet points, or BACnet or Modbus points that can be used in the BMS in the same way as any other any other BACnet point if you had a traditional wired sensor in there. So that's exactly it. So the sensors are battery powered with the option of putting a 24 volt on there if you want, but I would say 99 cases out of 100 the people will use the batteries, because it's a little bit counterintuitive to have wires in a wireless sensor. So the option is to go wireless, and if you get 5 years out of a battery life, I think that's pretty good. And the hub is going to be in your panel anyway. That's going to be where you have access to power. But that is 24 volt powered, yeah.
Okay. We have Kurt McCormick, who is our technical director here at Alps Controls. He would like the audience to know that he has this system working in our office here in Pittsburgh. And if anyone would like to call and he could do a quick webinar with them, he's happy to do that. He has sensors in the building next door and sensors 2 floors away. And he would like you all to know that it works great.
Okay. Thank you, Kurt.
We have another question. Can the sensors be calibrated, and what is the lifespan of the sensors like CO2?
Okay, so they're not designed to be calibrated is the answer there. So it's for sort of general HVAC applications. So again, I'm not saying that they can't be, but they haven't been designed with that in mind. So that's generally a HVAC application. So I'm going to say no for now, but that doesn't mean that they can't be, but that wasn't part of the design brief for them to be calibrated. What was the second part of that question, please, Alan?
Oh, it was just, can they be calibrated, and what is the lifespan of the sensors like CO2?
Yeah, it's going to be identical to the wired CO2. So it doesn't expire essentially. So it's I expect it to last 10 years plus, no problem.
Let me interject on that. Typically, my experience is that CO2 sensors should be calibrated every year, or worst case, every other year, because they do degrade over time, away from calibration. However, I've been selling CO2 sensors for 30 years. We have never once sold a calibration kit that we have available. So I don't know if people don't buy our calibration kits or they just don't calibrate sensors, a CO2 sensor. So I don't know how to answer that question. You probably need to calibrate it to stay in range or over a several year period of time, but I don't know of anybody that does that.
We have a gentleman who wants to know, can we push and pull data to the LoRaWan sensors from a BACnet controller that is through the gateway?
Push and pull. Obviously, you can pull them because that's so the signal comes from. Yeah, so there would be no need to push information because of the fact that there's no outputs or anything like that on the sensor. So there's nothing you can do on that side. But of course, you can pull information from it because that's exactly what it's designed to do. So the sensor information comes into the hub, and from there it's pulled into the BMS, and you use the same control strategy as you would use as if it was a wired sensor.
I think that's all the questions we have lined up right now.
Could I interject one last thing? All the questions were on the LoRaWan sensors, and I didn't see any on the smart communicating sensors. I don't know if that means people didn't understand or care about the uniqueness of that product or why there weren't any questions on there. I hope everyone understands the cost savings of using a sensor like that, a multi-point sensor that has I/O built into the sensor. If you have any questions on that or don't think there's a value in it, please reach out and contact me. I'd like to discuss with anybody that doesn't understand or doesn't need that sensor, because that caught me by surprise that the questions were all on LoRaWan and not on the smart sensor. But thank you everybody for your time. Also, let me know if you like these solution series. We can do more of them if you'd like. Thanks for attending this one. I appreciate it. Thanks for
thank you to everybody for attending, and thank you to alpscontrols.com, to Dave and Alan and all the team at Alps Controls for giving Sontay this opportunity. Really enjoyed the experience, and look forward to what comes from it. So thank you very much.
Thanks everybody. Bye.
Thank you.